Hello, and welcome to this IST 454 lab, Hash Cracking with Team Aldebaran. Our team consists of Andy Wolpozeski, Ben Williams, Ben Radomski, Mike Nelson, Ryan Glynn, Vitaly Kovalchuk, and Wes Marziano. Throughout this lab, we're going to be discussing the topic of decrypting hashed passwords. We'll explain the purpose of using graphical processing units, also known as GPUs, which can be found inside a graphics card, to decrypt hash values. These can be used to carry out brute force attacks on password hashes in order to recover the plain text password. This process is also known as hash cracking. In this video, we'll cover what hashes are, what they're used for, and why someone would want to crack hashes. There will be an overview of current technologies that are commonly used in hash cracking, and an explanation of the advantages of carrying out the process using GPUs rather than a computer's central processing unit, or CPU. Finally, we will discuss some possible scenarios where hash cracking could be applied. The purpose of this lab is to demonstrate a unique method of decrypting hashed passwords. The method involves taking advantage of a computer's graphics card instead of using your computer's central processing unit through the use of online, freely available, and open source tools. Before we begin, we need to develop an understanding of what hashes are. The term hash refers to the mathematical value output by a one-way function, called a hashing algorithm. Each generated hash is unique and depends on the text or file input. Displayed on the screen, you can see an example process of hashing a text file, and an MD5 hash value generated for the text password. Any change to the input would result in a change to the hash value output by the one-way function. For this reason, hashes are often used to ensure the integrity and authenticity of files. Should a transferred file's hash match the value of the original, you can be sure that its contents have not been manipulated. Hashes are also used for storing passwords in databases, so that plain text versions of the passwords are not easily obtained. However, we're going to demonstrate that having the hashed version is often sufficient in the event that you're trying to obtain the plain text password. A few hashing algorithms, such as MD5 and SHA, are commonly implemented. Others exist, but are seen less often in practice. For this reason, we're going to crack a hashed password generated using the commonly used MD5 hashing algorithm. Our lab demonstration will familiarize the audience with utilizing graphical processing units for the purpose of decrypting password hashes. It has been shown that using certain technologies associated with graphics cards leads to the ability to brute force hashed passwords much faster. The image on the right shows the comparison of brute force attack speeds between graphical processing units and central processing units. There is a clear difference in performance that indicates that it is more feasible to take advantage of GPUs to carry out brute force attacks. The two commonly used platforms that utilize the graphics processor for computation are NVIDIA's CUDA and AMD's OpenCL. Both of these platforms can be utilized to accomplish faster computing by offloading specific tasks from the CPU onto the GPU. There are various possible scenarios where password hash cracking could be used for both legitimate and illegitimate reasons. Hash cracking can be used legitimately to recover passwords. For example, Windows machines hash user passwords using the NTLM algorithm. If a user forgets their password, access to the password's hash could potentially lead to recovery of the plaintext version. Alternatively, an individual with access to a database containing users' hashed passwords could attempt to recover the plaintext versions by brute forcing the hashes. Now we're going to show you how to prepare your machine to carry out the lab. For the demonstration, we will be using a 64-bit Windows 7 machine with an NVIDIA GTX 260 graphics card. Drivers are the software pieces that interact between the hardware and the operating system. To prepare, we will use a web browser to obtain the latest video drivers for your graphics card. In order to obtain the latest drivers for the NVIDIA cards, you can go to www.geforce.com/drivers and run the auto-detect to detect the installed graphics card if you're unsure which card you have. If you happen to own an AMD graphics card, you can go to support.amd.com and click on Drivers. There's also an automatic detection tool available here. Next, we're going to obtain the open source software tool we will use called Hashcat. To download the tool, go to hashcat.net. On the left side of the screen, there should be a menu link called Hashcat GUI. Once clicked, the latest version will appear. The last tool we're going to use is an online MD5 hash generator. It allows a user to input a string of characters for which it will generate an MD5 hash. The website can be accessed by searching MD5 generator on Google. Now that we have completed the setup, we are ready to carry out the lab. Once the Hashcat software has been downloaded, in our case, we save the file to the desktop, we can extract it since it's in a zip archive. Using software such as 7-zip, we're going to extract the software to the desktop. It will create a folder and place all the extracted files there. Once the extraction is complete, we can open the folder with the software. We're going to navigate to the file called hashcat-GUI32, which launches the Hashcat program. Now we're going to proceed to start the program. A pop-up window should appear that has 3 buttons. One called CPU Only, which will utilize the CPU for hash cracking. One called NVIDIA CUDA, for people to use their NVIDIA graphics card. And the last one is called AMD OpenCL, for people with AMD graphics cards. For this demonstration, we will select the NVIDIA CUDA option since we're using an NVIDIA graphics card. Once the option is selected, the program GUI should open. As you can see, there are 3 tabs located at the top. Each one of these tabs represents different versions of Hashcat that are capable of performing various attacks on hashes. For this lab, we will use the CUDA Hashcat Lite tab. It contains all the necessary features to carry out our hash cracking process. The first thing we need to do is to input the hash into the hash field. We will use the MD5 online hash generator to generate a hash for this program to crack. Our password string will be S3CR3T5, or secrets. It's a 7-character password that has numbers and letters. We click Calculate MD5, and now here's our MD5 hash of the password. Now we copy and paste it into the Hashcat hash field. There's a drop-down menu for selecting a specific hash type. We're going to select MD5, but there are many other options depending on which hash you'd like to brute force. Next, we will select custom character sets, which will specify which characters the program will use to carry out the brute force attack. We will use $L, which includes all lowercase letters, and $D, selecting each of the digits 0 through 9. Next, we'll go to select the possible password length. We selected 4 to 12 characters for the most likely scenario. The resources options are for configuring the GPU, and we can leave them with default settings. The output options allows for writing the recovered hash to a file, which we will not use in this demonstration. Now we will hit Start, which will execute the program. It will ask you to agree to the terms and conditions by typing in Yes. Now a terminal window should pop up to display the progress of the brute force attack. There is information provided about the current configuration of the program, as well as some information about the graphics card. We're going to type S into the terminal to see the current status. The window will provide us with status information, including speed and progress of the brute force attack. In our case, we can see that the GPU is processing approximately 630 million guesses per second. CPUs, in comparison, can only do about 1/10 the speed of such processing. After about 2 minutes, the program successfully outputs the plaintext character string. As we can see, it matches the password we used to generate the MD5 hash. In this lab, we have learned that using GPUs to brute force attack password hashes results in much quicker decryption than using CPUs. We have found that a 7-character MD5 password hash generated using lowercase letters as well as numbers for the password can be successfully decrypted within 4 minutes. Any password length less than 7 characters can be brute forced within a matter of seconds. Password hash generation is used in cyber forensics to ensure the integrity of evidence, while password hash cracking is used in investigations to recover passwords. Thanks for watching this IST 454 lab. If you want to learn more about password hash cracking, you can visit the websites displayed on the screen.